Welcome to the Year 11 PPE Paper 2. This is the first of the calculator papers. Just a reminder, you must show all your working to get full marks, and although you're allowed to use one of these, you still need to show how you get your answers. Okay, first question. Now, these papers are edited versions of the original paper from one of the exam series, and there are a few mistakes in the printing of the paper and spelling mistakes. You'll see them as we go through. Okay, so we will start with this one. This is a frequency polygon. Two things are wrong with it. The most obvious one is that the start and end points are not supposed to be joined together. So you just need to say that. Start and end points, start, end points joined, because that's what's wrong with them. It says what's wrong with it, so that's it. Okay, and for the second reason, I noticed that one of the data points, I'm just going to highlight it, is at 15.8, but it should actually be plotted at 15,6. So I'm just going to say that 15,6 plotted incorrectly, or just wrong, I suppose you could say, incorrectly at 15,8. So you don't need to say a lot here, but what you do need to say is something that's specific and concise and accurate. Okay. The height of a book is 218 millimeters. Correct the nearest millimeter. Complete the error interval. So what we need to do here is write down the minimum it could have been before the rounding to 3 significant figures, or to the nearest millimeter. So it could have been that, and it could have been up to, but not including, that's what that one means, 218.5. That's all you have to do for that mark. Okay, this is a ratio question. Callum's stamps to Isabel's stamps. There's the first spelling error above. Okay, we've got first of all, we've got 275 stamps. We've got to divide them in the ratio of, we've got to divide them into 11 parts because there's 3 plus 8, you see. I'll put 3 plus 8 there. Okay, now that makes 25, okay, which means that Callum has 3 times 25, 3 parts, which is 75. Okay, and Isabel has the rest. Okay, now after Callum buys stamps from Isabel, we now have 275, okay, divided by 5, because that's the new ratio. Well, it's 3 plus 2, okay, which is 55, okay, and Callum has now 3 parts of 55, you see, okay, which is 165. Now we don't need to know how many stamps Isabel has. We could easily work it out, and we could use that as a check, but we don't need to. If we're confident with what we've done here, we can now say that Callum, because it says how many stamps does Callum buy from Isabel, well, it's simply going to be 165 take away 75, which is 90 stamps. Okay, so you need to show all your working, but there's no need to show unnecessary extra things that you don't actually need to do. Okay, next question. This is about a company that's giving a shopping voucher to its employees, and it picks a sample of 70 people from the company and asks them what vouchers they would prefer. And these are the results out of those 70. Well, there's the second mistake. There are 900 people in the company. So what we've got to do here is we've got to take that proportion, 28 out of 70. That's the fraction of people from that sample who said they wanted Marks and Spencer's, and multiply it by 900. Okay, put that on the calculator and you get 360. Okay, so that means that if those 28 people were representative of the whole company, sorry, those 70 people were a fair representation of the people in the company, that's how many Marks and Spencer's vouchers you would need. But what we've got to now do is write down any assumptions we've made and explain how this could affect your answer. Well, the assumption is that we've assumed the sample is fair. So I would say assumed sample is, well, the best word to use is representative. Okay, representative. And therefore, what effect could it have on the answer? Assumed sample is representative. Otherwise, the answer would be wrong. I mean, that's all you can say. Otherwise, answer could be wrong. Okay, it's sometimes difficult to work out exactly what they want you to say for these things because you seem to be stating something that's very obvious, but you nevertheless have to do your best to put down a reasonable answer. Okay, next, two graphs to be identified. One of them is y equals x squared. Well, that's a parabola. It's that reflected shape in the y-axis, symmetrical about the y-axis. It's that one there. Okay, so that's graph A, and the other one is y equals 1 over x minus 1 over x, which would actually be graph C. Okay, this one here. Okay, this is 1 over x, this is minus 1 over x. Okay, next. Right, now this is an interesting little question. You've got to show that there's only one number that is in both of these sequences. Now the best way to do this is just to generate the two sequences. So you think of, you've got 2n squared plus 1, and you've got the second one, which is 65 minus 2n squared. Now it's just like a little table, and I'm just going to put n across here. So n is the number 1, 2, 3, 4, 5, and I'm just probably going to generate about 6 terms. So when n is 1, 2 times 1 squared plus 1 is 3. 2 times 2 squared is 2 times 4, which is 8, plus 1 is 9, and so on. And I just work through the sequence, and I do the same with 3, put 3 into here for n, and I get 19. When I put 4 in, it comes to 33. When I put 5 in, it comes to 51. Okay, and I'll just go one more, and it's 73. Okay, now if I put 1 into this one, I get 65 minus 2, which is 63. So this one goes down, and then I get 57. Okay, by putting 2 in. By putting 3 in, I get 47. Then it drops down to 33, and then it drops down to 15, and then it drops down to minus 7. Now, the reason I'm going that far, I can see the 33, that's come up quite soon in both of them. So that's the number that appears on both sequences. The reason I'm going further is to make sure that as this one comes down, it doesn't overlap with anything at the bottom here, which it doesn't, because it's now gone to -7, you see, and it's just going to carry on going smaller for the time being. And this one seems to carry on going up from here, so it's already gone past 63. And so the answer there is 33. Okay. And the working above is more than sufficient to show how we got that answer. Okay, next. Now this question is for the calculator. It's a question about calculating something and giving the answer in standard form. You can type it exactly like that with the brackets. There's a button on the calculator in the middle of the bottom row normally, which is times 10 to the power of. You can also do it on the using a fraction facility. So set a fraction up on the calculator. On the top line, use that button I told you just now, times 10 to the power of -5. And then underneath the fraction you can put the other one. Okay, 7.5 times 10 to the -8. Okay, and when you put that in, you should get 576. Okay, 576, and that then must be given in standard form, which is 5.76 times 10 to the power of 2. Okay, so the part at the front has to be a number between 1 and 9.9 recurring. Okay, so this question 8 is about the number of days that it will take to run a marketing campaign. It's given by that formula. And you've got some information about Alex's and Shay's companies, and what you've got to do is work out the number of people needed for each of those days. So I'm just going to rearrange the formula. So basically swap the n and the d over. So if I divide both sides by d and multiply by n, I get that n is 192 over d. Okay, now for Alex, okay, I can see therefore that that's going to be 192 over 32, and that's exactly 6. And for Shay, it's going to be 192 over 24, which is 8. Okay, and the question is, how many more days does Shay how many more people does Shay need than Alex? And it's 2, because it's simply 8 minus 6 equals 2. Okay, so quite a simple question, that one, really. Next we have a cuboid and a cube, and we've got various information about the dimensions of this one, and ultimately we've got to find the volume of the two and compare them. So what I'm going to do first is a sort of table actually, which will help us work this out. So I'm just going to, on one side I'm going to have the cuboid, and on the other side the cube. Okay, and then I'm going to have information about the volume and the surface area. So in this first top half I'm going to be talking about the volume, and down here the surface area. Okay, and in this one I'm going to be talking about the cube, the one on the left, and in this column here the cuboid. So all my working is going to appear in these boxes. Okay, so what I'm going to do is start with the information I've got about the cuboid, and that is that the volume is going to be simply 3 times 4 times 9, okay, which is 108. Length times width times height. Okay, now I'm going to go and do the surface area. Now there's two surfaces of 3 by 4, Okay, so I've got 2 lots of 3 by 4. That's like the front and the back. I've got 2 surfaces of 9 by 3. That's this one here and the one over here, sort of the left and the right faces, if you like. So I've got 2 lots of those, which is 2 of 3 times 9. And I also have 2 lots of 9 times 4, or 4 times 9, which are like the floor and the ceiling, the top and the bottom. Now if I work those 3 numbers out and add them together, okay, that will give me the total, which is 24 from here. Okay, from here I get 54 and 72. Okay, if I add all those together, I get total, which is 150 exactly. Okay, 150 is the surface area. I'm not putting units in because this is just working out. Okay, now if the surface area of that's 150, the surface area of the cube is the same, so that's also 150. But that's made of 6 faces, right? So if I take 150 and divide it by 6, because there are 6 equal faces, it means each face has an area of 25. Okay, that's one face. Okay, one face of the cube. Okay, and if I take that 25 and square root it, it gives me 5, which is the length of one edge. Okay, that's the edge of the cube. And if I've got an edge of 5, then for a cube, I just cube it to give me the volume, which is 125. So to answer the question, Amy says the volume of the cube is different. There should be an is in there. Different to the volume of the cuboid. Is Amy correct? Well, yes, Amy correct. Okay, because yes, correct. And we just need to say something like, well, it's really obvious, since 108 is not the same as 125, which are the 2 numbers we calculated for the volumes. And that's it. Okay, next question. Make K the subject of the formula. Well, all we have to do is rearrange it. I'm going to square both sides first to give me that y squared is equal to k plus 5m. And now all I need to do is subtract 5m. So k is going to equal y squared minus 5m. As simple as that. Okay, next question. This is about box plots and the distribution of data, and we got to make comments and comparisons. So what's going on here is it's talking about the turnips that William grows, and it's the weight of those turnips. Okay, and you can see that the median weight is 57 grams, and William is saying that half of his turnips weigh more than 50 grams each. Well, if the median is 57, what it means is that half of his turnips weigh more than 57. So if in that respect, they certainly weigh more than 50. So the best way to answer this is to say that he is correct. Okay, and the wording of the question is a little bit confusing, but it is correct since the median, and this is the key word they'll be looking for, since the median equals 57 grams, which is greater than 50 grams. Okay, and that's how I would answer that question. and I've just noticed, of course, that we've got guests here, Megan and Amy. This is edited, I think, from a previous version of a question like this. Anyway, William says that we've done that part. Now, Ryan also grows turnips. The box plot shows information about the weights of Ryan's, and we got to compare the distribution of the weights of William's to the distribution of the weights of Ryan's turnips. There's two things you need to do here. You need to compare the medians, and you need to compare the interquartile range, some measure of the spread. So with the medians, I'm going to do that first. Okay, I'm going to do it like this. I'm going to say William, so William's median is at 57, is greater than Ryan's at 42, if you look at the box plot there. And for the other part, which is the spread, the best measure of spread is the interquartile range. Okay, so there's the medians, and these are the IQRs, the interquartile ranges. So I can say that William, and that's also greater. Now his interquartile range is the difference between 65 and 39, which is 26. Okay, make sure you get those right, and that's greater than Ryan's, okay, which is at 16. Okay, so that means that Ryan's turnips were more consistent in size, whereas in weight, whereas the weights of Williams were more varied and spread out. Okay, and that's how I would answer that question. That's part B there. Okay, and that's all part B, and this is part A. Okay, but don't spend too long on those sorts of questions. Put down something concise and factual, and move on. Okay, this question concerns some sides on right-angled triangles, so it looks like it's going to involve trigonometry because there's angles as well, and indeed it does. So we have got to use all that information in the diagram to work out the size of the angle EAD, that one in there. Okay, now before we can get to that, we need to know something else, and we need to note that these two lengths here, BE and ED, are the same because E is the midpoint of BD. Now I can work out the length of the line BD using trigonometry, sine, cos and tan. In fact sine, because the length BD is opposite the angle 42 and the side 9.2 is the hypotenuse. So opposite over hypotenuse is the sine of 42, okay? Which means that if I multiply both sides by 9.2, that the length BD is equal to 9.2 times the sine of 42 degrees. Okay, make sure your calculator is set to degrees before you go into the exam. Now, the next thing to do is to say, well, actually, I want the length DE because that's going to enable me to find this angle in here. All right. Now, DE is half of BD. Okay, so DE is going to be the thing I've just calculated here or written down divided by 2. So if I write it like that and then divide that by 2, that will give me the length of DE. And on the calculator, that comes to 3.0780, 3.0780, in fact, and there's a few other numbers after that. And that's DE. So if I've got that length now as 3.078, that's to, well, at least 3 decimal places. I can now use these two to work out this angle here, which I'm going to call, let's just give it a name, I'll call it theta, to save writing down angle EAD. So theta, okay, the tan of theta, okay, is the opposite, which I've got, which is 3.078 over the adjacent, which is 4.5. Okay, so therefore I just need to rearrange that and use the inverse tan function on the calculator. So theta equals the inverse tangent, okay, of that fraction, okay, which I've just written down. Make another copy of it, and then put that in brackets when you put it on the calculator. Okay, so you need brackets around that, and in fact the calculator puts the first bracket for you. You've got to close the bracket off at the end, and you put shift tan to get that, and that comes out to be 34.372. okay, 34.372, but the question asks for it to one decimal place, so it's going to be 34.4 degrees to 1 dp. Okay, and there's the answer, and make sure that you have shown all of that working out to get all those marks. Okay, next question. So this is quite a complicated little question concerning compound interest. So basically, you start with £3,550, okay, and it's going to be invested for 3 years. Okay, now in the first 2 years, it earns interest at 2.6% per year. Okay, so what we do is we multiply that by 1.026, okay, which makes it 102.6% of what it was, okay, which is 2.6% more, and we do that for 2 years, so we square it, okay, and then in the third year we increase it by R%. Now to make the multiplier for that, we create 100 plus R over 100. Now, it's easier to understand that if you think of an example. So, for example, suppose R was 3%, then this number I'm writing down would be 103 over 100, which is 1.03, you see. Okay, so that's how it works, but we've got to find R. We don't know what it is, but we're going to solve an equation, and we know that the result of that is 3,819.21 at the end of 3 years. So I'm going to solve this equation, and I'm just rearranging it. So if I take all this and divide it but the right hand side by that, it will give me 100 plus R over 100. Okay, so all the stuff in front of it is now going to be divided away, and that's going to equal, okay, what I had over here, okay, which is that, and that's going to be divided by all of this stuff I had here in front of the first bracket. So if I just select that out, okay, and that now goes underneath there. Okay, so that division will give me 100 plus R over 100. Okay, so if I now times both sides by 100, that will turn that 3819.21 into just 381921 without the decimal point. And then I need to subtract 100. So I can do that in one go. So R would be equal to all of that without the decimal point. So I could just take another copy of that. That would save some time. Okay, so all of that. Okay. And without the decimal point, so I can just take that out. And that then needs to be that's taken care of, that 100, and I just need to subtract 100 from that, and that will give me the answer. Okay, so if I put all that into the calculator, that big fraction there, okay, doesn't need to be in brackets actually. If you put it in exactly like that, don't forget the squared there, subtract 100, and you'll find that that comes to 2.199. Okay, 2.199, and then it goes 89, and then there's lots of other digits. But the question said give your answer to one decimal place. So therefore R equals 2.2%. Okay, 2.2% to 1 dp. Okay, but you must have all the working to support you. It's particularly important with this question because you could quite easily end up with an answer that also rounds to 2.2 but comes from incorrect working. All right, and if they don't see the working it's come from, you won't get the marks. So you must show clearly how you got your answer. Okay, Daniel's going to buy pizza. He can choose from a variety of toppings, sizes, and varieties. So what we're going to do is work out that if the total number of pizzas he could choose from is 3726, what's the missing number? So basically, I know that if I take the number of varieties times the number of toppings and times the number of sizes, okay, then I get 3726. Okay, but I know two of those numbers. I know that V is 23, and I know also that T is 18. So the one I don't know is this number S. Okay, make sure that looks like an S, not a number 5. Okay, so basically what I'm saying then is that S equals 3726 divided by 23 times 18. Okay, and if you put that on the calculator it comes to exactly 9. Okay, and you'd expect it to be a whole number. Now the next question is an expansion of 3 brackets. Now the best way to do this is, there's 3 ways. You could take any pair of brackets and multiply them together, then multiply the result by the third. The best way is to actually leave the first one in place and work on the second 2 here. Okay, so I'm just going to multiply those 2 brackets together using FOIL, first outer inner last. So this thing here becomes the same as 5x plus 3, which is the first bracket left alone, but then I'm going to do FOIL here. So first that's 3x squared. Okay, then I've got to do the inner terms and outer terms. Well, 3x times 3 is 9x, minus 2x is 7x, so it's 3x squared plus 7x. Okay, and then I've got minus 2 times 3, which is minus 6. So that's quite easy to do first. So I've done first, outer, inner, and last. Okay, to get that result there. And now I'm going to take this bracket and multiply it by this one. So this is going to give me in total 6 terms. So I'm going to do the 5x with the 3x squared, which will give me 15x cubed. Okay, then I'm doing the 5x with the 7x to give me 35x squared. Okay, and then I'm doing the 5x with the minus 6 to give me minus 30x. And then I do everything in the second bracket with the 3. 3 times 3x squared is 9x squared. Okay, then I've got 3 times 7x, which is 21x. And finally, I've got 3 times minus 6, which is minus 18. Now, the next thing is to pair off similar terms. So I've only got one x cubed term, so that just stays as 15x cubed. Okay, but I've got 2x squared terms, 35x squared and 9x squared, which combine to give me 44x squared. Okay, I also have 2x terms, minus 30x and plus 21x, which gives me minus 9x. And finally, I have a number on its own, without any x's on it, which is minus 18. So that's the full answer, simplified, with 4 terms in descending order like that. Okay? Right, next question. Okay, this is an interesting probability question because it's asking us about the probability that the product of any 2 cards taken at random is an even number. Now, the first thing I'm going to make a note of here is that you've got in there 3 numbers that are even, so 3 even, and you've also got 6 numbers that are odd. Okay, so even and odd. Okay, so that's quite important. Now, for a product to be even, it can happen in 3 ways. You can have even times even. You can have odd times even. That's always even. Or you can have even times odd. They're the 3 ways in which you can have an even number. The only way in which the product could be odd is if you had an odd number and then another odd number. So both numbers picked would have to be odd. So the probability that the product is an even number is the same as 1 minus the probability that both cards you select are odds. That means the first is odd and the second is odd. Okay, well, that's the easiest way of working it out because it's 1 minus the probability that the first one is odd is 6/9. Okay, and if the first one was odd, the probability that the second one is odd as well is going to be 5/8, because you've now only got 8 cards left and only 5 of them would be odd. Now if you put that in the calculator, that's equivalent to 1 minus, well, you can just go straight to the calculator, but I'll just go through a little bit more, 30 over 72. And that, of course, is 42 over 72. And that's the answer. Now, you can simplify it, okay? They both divide by 6, which gives you 7 over 12. But you don't actually have to do that because it doesn't ask you to. But if you did it on the calculator, it would give you that answer, 7/12 in lowest terms. So that's the quickest way of doing it. The other way is to work out the probability of each of these 3 events and then adding them together and subtracting, and that would give you your answer. but it would take a lot longer to do that. Okay, so this is the quickest way for sure. Next question. Okay, now this looks like it's going to be a bit of a circle theorem type question, and it may have, yes, it does have some circle theorem involved in it, but not a lot. So basically what I'm going to do here is recognize that a tangent meets a radius at 90 degrees. Okay, and that enables me to work out the angle here, which is 62. Okay, 62 degrees in there. Okay, now it says you must show all your working, which I'm doing as I go on here, and that's okay because it's not asking me to give any reasoning, any angle reasons, so I don't have to write much down, but I do have to do some working out. So I'm just going to show that this angle here, okay, is, I'll just write the angle in. It's going to be 118, okay, because it comes from 180 minus 62. So I'm just going to put the working here. 180 minus 62 equals 118. Okay, and then these two angles here are both going to be equal, and they're going to be the two angles left over from taking 118 from 180, which is 62. Okay, so 180 minus 118, well, we know that's 62 because we've just done it in reverse up there, but we're then dividing it by 2 because that's an isosceles triangle here, because these are both radiuses. So those two angles must be the same, and they are indeed half of 62, which is 31. Okay, so this is 31 and this is 31. And on a question like this, you're encouraged to write the angles in as you go. So the angle we want, which is CAB, okay, is going to be 90 minus 31. So that angle there, I should have shown you that earlier. That's the one we're actually looking for. Okay, so angle CAB equals 90 minus 31, which is 59 degrees. Okay, and that's the answer. Next question. Okay, this is about histograms. Now, the thing to remember here is the area of each block represents the frequency. So what I'm going to do is use the frequency density, 12 times 1.5. This represents 18 of sculptures in the park, okay? And this here is 20 times 1.5, which is 30. This one here is 28 times 3, which is 84. This one is what we've got to find, because it says we basically need to find the 20% of the sculptures that fit between 6 and 7.5 meters, the missing bar. Okay, and this one here is 7.5 times 8, which is 60. If we add those four numbers together, we get 192. Okay, so 192. And those four bars represent 80% of the sculptures in the park, because the other 20% are the ones missing. So if that 192, which represents 80%, okay, if we divide that by 4, okay, 192 divided by 4, that will give us what 20% represents, which is 48. Okay, so 20% is represented by 48. So this bar that's missing has to be representing 48 sculptures. Because this has got a width of 1.5, we do 48 divided by 1.5, to give us the height of that bar, which is 32. So this bar here, with a height of 32 and a width of 1.5, is the missing bar. Okay, draw it down to there and down to there. You don't need to shade it in, just make sure it's drawn clearly and it's readable. Okay, so I'll just show you with this where it is, because it might be difficult to see on the screen. Okay, but that's the missing bar. Okay, next question. Simple volume problem. Don't forget that this is a hemisphere, half a sphere. So if that's the volume of a sphere, we want 2/3 of pi times the radius, which is half of 10.6 cubed. Okay, and we need to give the answer to 3 significant figures. Well, it comes to 311.8 something on the calculator. So that's simply 312 centimeters cubed to 3 significant figures. Okay, as simple as that. Next. Okay, now this is about upper and lower bounds or limits of accuracy. And this number C has been rounded to 3 significant figures. Okay, so if we take the number C and we look at the lower bound and the upper bound, what could it have come from to be rounded to this? Well, the lowest it could have been is 11.85 and the highest is 11.95. So what we now do is use in the calculation d equals 1/7 of c squared, each of these two numbers into c and then square them. So if we put 11.85 into this formula, it gives us that d equals 20 point, okay, 20.0603, and then there's more to it after that, and then this one gives me 20.4003 and so on. Right, now the next thing we have to do, because it says give a reason for your answer and by considering bounds work out the value of d to a suitable degree of accuracy. So what that means is, suppose I rounded them both to 3 significant figures. This one would be 20.1 in fact. This one would be 20.4. Okay, so they're different. They don't agree to 3 significant figures. However, if I said let's try 2 significant figures, we would find that that's 20 to 2 significant figures, and so is this one. So they agree to 2 significant figures. So I answer it by saying d equals 20 to 2 significant figures, since upper bound and lower bound agree. Okay, to 2 significant figures. Next, this is a speed time graph. Okay, so the area under the graph is the distance. Now, what we've got to do is calculate the time taken to travel half the distance. So before we can do that, we need to know what the distance is. Now, the distance is the area. Now, you could do this as 2 triangles and a rectangle, or you could just do it as a trapezium. Now, if it's a trapezium, it's you add together the 2 parallel sides. So it's 200 plus 100, okay, because that's 100 across there from 60 to 160. Okay, divide that by 2 and multiply it by the distance between them. And this is the quickest way of doing it if it's a trapezium. Okay, and you times that by the distance between them, which is 12. Okay, and that comes to exactly 1800. That's the total distance between the two stations. So half the distance is going to be 1800 over 2, which is 900. Okay, now the question says, at what time will it have covered 900 meters? So we got to sweep through and find out. And I could use another trapezium, or I could use a triangle. It might be easier to do the triangle and then part of the rectangle. So imagine moving from left to right through here. The area of this triangle you can work out to be 360. Okay, but I've got to get to 900. So I've got to go some way into this rectangle. How far do I need to go in? Well, if I start with my 900 and take away the 360, that gives me 540 meters to go. Okay, so if I'm in a rectangle that's a height of 12, okay, that's 12 there, what's the length I need to go in to cover an area of 540? So I do 540 over 12, okay, which gives me 45. Okay, so it's telling me that if I went in 45 into here, so that's 60, 80, 100, and that's 105. Okay, it's just past that little point, it's about there. What I'm saying is if I went that far in and went up there, everything I'm cutting that area into half basically. Okay, so it happens at the beginning of the rectangle is at 60, and 45 units into it takes me to 105. So the answer to the question is 60 plus 45, which is equal to 105 seconds. Okay, that's how far into the journey I am when I'm halfway in distance. Okay, and the second part, compare the acceleration of the train during the first part, that's here, to the acceleration at the end. Well, the main thing you have to notice is that so this is part A. So for part B, all I need to do is say acceleration at start is positive. Okay, that means it's increasing its speed. Positive, you can use that abbreviation if you like. And the acceleration at the end is negative because it's slowing down. Okay, which is kind of obvious, but that's what you need to say. Another word for that is deceleration. Okay, you could use that instead, that it's decelerating. And you could say that it's decelerating at a steeper rate, or it's steeper there than it is there. Okay, which means it's slowing down more harshly than it's speeding up, but they don't require that. They just wanted to know that. Okay, next. The number of rabbits in a farm at the end of a month is Pn. The next month it's Pn plus 1 and so on. So at the end of April there are 400 rabbits. So we start with 400. How many rabbits at the end of July? So let's do the months. So at the end of May, okay, if I just write May there, then that's going to be equal to 1.1 times 400, okay, minus 20, which comes to 420. Okay, and at the end of the next month, June, you're going to have 1.1 times 420 minus 20. Okay, that comes to 462 minus 20, which is 442. So it's gone up by a bit more that time. And then for the end of July, okay, you take that number you've just got, 442, times that by 1.1 and take away 20, and you get 466.2. Okay, and that's got to be 466 rabbits. It's got to be a whole number. Okay, so it's growing at a faster and faster rate. So considering your results from A suggests what will happen in the farm for a long time, and you just need to say that it'll be overrun with rabbits or something like that. In other words, the number of rabbits will just get out of control. Okay, next. Now this question is concerning a parallelogram with an angle between two sides given algebraically. And we know that the area has to be greater than 11. So what we're actually going to be using here is the fact that the area of a triangle, okay, is a half AB sine C. Okay, so if you know two sides and the angle between them, you can use that formula to find the area. Now, of course, this isn't a triangle, it's a parallelogram. And if I put a line across there, okay, that would divide it into exactly two triangles. So that triangle there is given by that formula. And then I've got another copy of it under here. Okay, so basically, I just got to say times 2. I'm just going to show this in note form for a parallelogram. Okay, so that's what I've got, a parallelogram like that, and that has an area that's basically made of two triangles, as I've shown you up here. Okay, so what I'm going to do then is say that if that's true, then I can lose the half. Okay, so I can say that AB sine, so A is 8 minus x, so 8 minus x times the other bracket, which is 3x plus 1, okay, times the sine of 150, okay, and I'm told that it's greater than 11. Okay, now the sine of 150 is the same as the sine of 30, which is a half. So therefore I can say that 8 minus x, okay, times 3x plus 1 times a half is greater than 11. Okay, so if I double both sides, I get 22, and I can multiply out these brackets. So I'm going to have 8 times 3x, which is 24x. That's the first. The outer term is plus 8. The inner term is minus 3x squared. And the last term is minus x times 1, which is minus x. The half I've taken to the other side and times by 11 to give me 22. Okay, 22. Right, so it's going to be a quadratic inequality. So what I'm going to do now is I'm going to rearrange the order of things and have minus 3x squared at the front. Okay, now I've got plus 24x minus x, which is plus 23x. Okay, and then I've got my plus 8, but I'm taking away 22. Okay, so that's going to give me minus 14, and that's greater than 22. Sorry, that's greater than 0 now, because I've just taken the 22 to the other side. Okay, now I'm going to multiply the whole inequality by minus 1, and you need to be very careful here, because if you do that, you change all the signs around here. Okay, that's easy enough, but you also have to swap this round for it to be true. Okay, and you can think of any numbers to test that out with. So following on from this, if I just come up to here, that factorizes into 3x and x, okay, multiplied by 2, the two brackets would have 3x minus 2 multiplied by x minus 7, and that would have to be greater than 0, okay? And I'm actually doing part B at the moment. I've just realised that I've gone beyond what I needed to do for part A. So really, at this point here, I had shown part A. So that's the end of part A there, okay? So what I've done since over here is actually the beginning of part B. So I factorised that quadratic, okay, so I'm doing it here instead of up there. And that gives me that x, to make this bracket 0, okay, x equals 3, it'll be 2/3, okay, and to make this bracket 0, x equals 7. Now those two values are what we call the critical values, okay, they're the points at which we've got to decide what happens, okay, the critical values. I'll just do a quick illustration of what I mean. Okay, so if you consider this quadratic equation that or quadratic inequality that I'm using, what I'm saying is that I've got this quadratic curve, this sort of shape like this, okay, and that I've got my two solutions at 2/3 and at 7, okay. That's the x-axis there. And they're the two places where the graph crosses the x-axis. Now I want it to be less than 0. So for that to be true, for the value of that graph to be below 0, then x has to lie between 2/3 and 7. So my solution is that 2/3 is less than x, which is less than 7. So basically it means if x is anywhere in that range, then the value of this, the area of this, will be greater than 11 centimeters squared. It's quite a good question, that one, and quite a lot involved in that. Okay, next. This is a transformation, a combined transformation, a reflection in the line y equals 0 followed by a rotation. Right, now if I take this shape and reflect it in the line y equals 0, that's the x-axis. It's going to go down here, right? So it's best to draw it on to see what's going on, okay? But the key thing to note here is, where does the point B go? Because that's what it's asking you about, because that's got to remain invariant. So B is this point here now in the reflection. Now I've got to now apply a rotation that will cause B to go back to where it was at the start. That's what it means. Now you might be able to see this. It's a bit tricky with a 90-degree rotation, but if I go to that point there, -1, 0, okay, and put those two lines in, not only have I got an angle of 90 degrees there, but the length of those two red lines is exactly the same as each other as well. And so a rotation this way, all right, so that's 90 degrees anti-clockwise, 90 degrees anti-clockwise will take me back, or will take B back to where it was. 90 degrees anti-clockwise, okay, and then you need to give the point, about the point -1, -1, yes, 0, okay, so that's called the center of enlargement. Okay, so you've got to understand what it means to talk about an invariant point. Okay, next and last. Okay, we have a line with an equation 4y plus 3x equals 72. Now we could write that as minus 3y equals minus 4x plus 72, which means that y equals minus 4/3 x plus a third of 72, which is 24. Now, if we do it like that, it's a little bit easier to see what's going on. So I'm going to sketch that line on some axes here, okay? And I'm going to put a y-axis here, an x-axis across here like that, okay? So this is just a sketch, and you can see roughly what's going on, and I might just change color here. So this line has a gradient of -4/3, and it crosses the y-axis at 24. Okay, so -4/3 is about that. What I'm telling you is that this point here is at 24. Okay, and by the gradient you can work out that this point here would be 18. Okay, which is 3/4 of 24. Okay, now that's the line L that they're calling L. I'll just put an L there. Now the straight line M is perpendicular to L and passes through A with coordinates 0, -1. So 0, -1 is about there, and this line L is a straight line. Sorry, this line M is a straight line that goes through there and crosses it at 90 degrees. It's perpendicular to the line L. So that's about 90 degrees there. Okay, so what I'm saying is there's a 90-degree angle, and this point here is at -1 on the y-axis. Okay, very good on a question like this to have some idea of what it all looks like. Now, the question is, they intersect at this point C. What's the area of the triangle ABC? So this is the point, I think this is the point they've called B, yes, and the point A is the one down here. So there's the triangle ABC. So we need the area of that. Well, if we call that the base, we can see that that's actually got a height of 25, if you like, because it's going from 24 to -1. So if we can work out this distance here, that's like the height of the triangle if you tip it on its side, then we could work out the area. And that distance is given by the x-coordinate of the point C. All right? So to find the x-coordinate of C, we need to set the equations of the two lines M and L equal to each other. So I have to put this line -4/3 of x plus 24 equal to the other line, which has a gradient of 3/4, okay, because it's the negative reciprocal of -4/3, and that line crosses the y-axis at -1. Now, if you multiply, if you multiply everything by 12 and solve that equation, that will give you now timesing this by 12 would give me -16, okay, -16x plus 12 times, so what I'm doing is I'm timesing everything here by 12, so 12 times 24 is going to be 288, and that's equal to, and this is going, I'm going to times this side by 12 as well to get rid of the 4, so that's going to be 9 times x minus 12. Okay, if I now let's add the 16x to both sides to give 25x, and add the 12 to both sides to give me 300. That will give me that x is exactly 12, okay, which is the x-coordinate of this point C. So that's the point there, 12, and you can almost see it looks about right, okay. So that is the x-coordinate of the point C. So basically this triangle has a height of 12 and a base of 25. Okay, so all I need to do is a half of base times height is a half of 25 times 12, which is 6 times 25, which is 150 units squared. I can't use centimeters because I don't know what they are, but I just say 150 units squared. Okay, quite a tricky question, that one, a lot to do there. And that ends the paper. So take care.